Visual scripting, previously known as Bolt, is a relatively new addition to the Unity ecosystem, but from 2021 it is available as a standard component in Unity editor. Creating scripts visually with drag and drop graphs instead of writing code from scratch may be an interesting option not only for those who have no previous experience as programmers, but also for those who simply prefer seeing the control flow nicely visualized as graphs. An obvious benefit is that you do not need to know C#. On the other hand, visual scripting isn't easy. You still need to know about Unity engine internals. You have to be familiar with components and their functionality. Visual programming is still programming, but without syntax errors. Also, graphs may be visually pleasing, but they quickly grow and may become a mess if you are not careful. Fortunately, this is Unreal Blueprint, not Unity. In this tutorial, we'll together develop a very simple game inspired by Fruit Ninja by Halfbrick and called Fruit Monster. In this game, instead of a fruit slashing knife, I have this green monster following the movement of the mouse, which can slash fruits and get points. Fruits are falling down from top to the bottom of the screen. When arriving to the bottom, they will start again from the top of the screen, and after slashing they will reappear in a random position and, as you can see, faster speed. Pearls will generate negative score, so you shouldn't catch them. In this tutorial, I will demonstrate the complete process of creating this game from scratch. So you should start with Unity Hub and choosing 2D Core as your project template, and then choosing whatever project name you wish. I have actually already started a fresh project. It is here. It's called Fruit Monster. It's completely new, fresh and empty, and ready to start. The first thing to do is to create a new asset folder. So right click, create folder, call it sprites, open the folder. Now I am dragging from the second screen I have here. I am dragging and dropping here the 4 images. We now have the 3 fruits, an apple, a cherry and a pear, and the goo, the green monster, which immediately ends up here in our scene hierarchy. Now I can run the game, and here we have it, the green monster. It's a little bit small, so let me stop the game, ensure that it's selected in the scene hierarchy, change the tool to scale tool, and now by dragging the central gizmo I can scale it up to around 2.5 of the original size. I will also rename goo into player, F2 and player, and restart the game. Now it's so much better. I will do one more small but very recommended modification to the project. As you might notice, each time I play the game, it takes time to reload script assemblies, and then hold on, it's doing various things. To speed the process up, go to Edit, Project Settings. Sorry, it's been opened on the second screen. Ensure that you have selected Editor here. Scroll to the very bottom, and here next to Enter Play Mode Settings, just check this checkbox. No, not the other two. This will speed the process of playing the game a lot. So now it's just immediate. Next, ensure once again that the player is selected in the scene hierarchy, and let's add components. The first component I will add is the box collider 2D. It is necessary because the monster, the player, will collide with fruits to collect points. So this is the new controller. We will check is trigger because we want to detect the collisions, not bounce off from fruits. I will also add rigid body, which is basically physics module in Unity, and I will change the body type from dynamic to kinematic. I can now roll up both components, and the third, you might say the most important component to add, is from the category of visual scripting, and you should choose script machine. State machines are also quite interesting visual tools, but what we need today is the script machine. Script machine is simply the host for visual scripting. So you can see that currently there is no graph here, but I can create a new one. Let's call it player graph maybe. Save it in the assets. Yes, that's the right place to save it. I can now click this folder in the project structure, and we can see our new player graph. To edit this graph, I could either double click here or click here, whatever will work. It takes a few seconds to start. And here it is, our first graph. For those of you who are at least a little familiar with Unity scripting, these two initial units or nodes should be quite familiar. On start is the starting point for the flow automatically initiated when the game object is spawned. And on update, it's the on update part of the command flow. So it's repeated around 60 times per second in each frame to update the object state. I will use the middle button of the mouse to scroll it so that I have the beginning of the on update on the left, in the upper left corner. We will not use on start at this stage. In this window, we also have the graph inspector, so I can see some details on the current graph, and the blackboard. We will use the blackboard a little bit later. The first task to do is to set the position of the player wherever the current position of the mouse is. To get it done, I will put another command or node right here by right click, add node, and I would like this command to set the position of my player. I have several different set positions to choose from, but again, if you know anything about Unity, you know that things like position, rotation, and scale are included in a component called transform, and indeed we have transform set position here. For this set position instruction to be executed, to be performed during the runtime, I will just connect these nodes, okay, and now we can run the game. The game does absolutely nothing at the moment, but first of all you can see these bubbles or whatever it is running from the left to the right. It symbolizes the flow of control, and this program now executes the set position function, as you can see, with parameter 000. So let me play with this or experiment. If I change it to 1, my monster has moved to another position. So this is how I can, during the runtime, I can experiment with the values of various objects. This will be position 3 in vertical direction as the coordinate y. Let me try -3 perhaps. Where is it? It's right in here. Then we have the z coordinate, which may be a kind of a surprise because this is a 2D application, and apparently this z coordinate doesn't change anything. In fact, my 2D object, my monster, remembers or stores or knows its z coordinate, z position, but moving it along the z line axis doesn't affect because we have a 2D camera to observe this guy. But whilst -9 is still here, if I change to -10, he disappeared. Okay, why did he disappear? This answer to this question is quite easy. If I look at the main camera object, you can notice that the main camera is positioned, even though it is a 2D application, at the z coordinate -10. So -10 here, or any further negative value like -11, will place the object either on the camera or behind the camera, and in this way it will be invisible. The best thing to have is to keep the z coordinate at 0. It's quite natural. 0 is where 2D objects should be stored. Okay, so stopping the execution. Next thing is to provide our set position function with coordinates of the current coordinates of the mouse. Firstly, I will change the selection back to the player. Right click, add node, and what it could be. Let's try something like get mouse. Yes, that's it. Get mouse button, get mouse person, get mouse position. So let me try to connect get mouse position, output of the get mouse position with the input of transform set position. Test it. Okay, and it doesn't work. Okay, why it doesn't work might be hard to think about, but visual scripting has a big advantage over text scripting or C# scripting in that it is a lot easier to debug, because if you look closely at the graph here, you will see that there is a value displayed here, and moreover, whilst I'm moving the mouse around the screen, this value changes. But if you have another look, right now the coordinate of the mouse are 607, 245. It's a lot, okay? You can remember, and I will remove this. This, for example, is the position 8, -3, 0. Okay, 8, -3, 0. And here we have like several hundred. Actually, if I would move the mouse to the very close. I can't even get it. Oh, yes, yes. So when I keep my mouse coordinates to the very lower left corner of the screen, I can actually see that this script is kind of working. But what we need basically is a mechanism that would convert these coordinates, which are called screen coordinates, to the coordinates that my monster can understand, and these are called word coordinates. So let's stop the application. Add another function, add node, how it could be called, screen coordinates, world coordinates, and we have it. Screen to world point. So as you can see, unlike C# coding, sometimes if you just have a vague idea what you want to do, it's easier to find the function that you really need, and you don't need to be constrained by C# syntax to get things done. Anyway, we have a camera function, screen to world point. Here you can read more details about it. We have to choose from between screen to world position I, or just position. What is I? I of camera input, I don't exactly know. So if this is the case, if I don't exactly know what the second parameter is, why to use it, why to make my life more complicated if I can take this one, okay? And this is screen to world point with just a single position, so don't bother with the I. We have a node which potentially should convert my mouse position from screen coordinates to world coordinates. So let's do all the connections that we need. Run the application, and this red color, which is also visible here, shows that we have a problem, we have an error. What this error is? There is no camera attached to the player game object. Okay, so let's have a look what it means. Indeed, we have a camera here, a symbol of the camera. Also, from a precise description of the node, I should notice that, yeah, this should be the camera. So we need the camera. It is quite obvious if you think about it. The screen position is defined, or screen to world translation will change depending on the position of the camera. If you move the camera to some other area of your 2D world, this translation should change. So we need the camera, we need this object. It's called main camera. So let me add a node. Would this work? Not exactly. Animation clip, definitely it's not going in the right direction. So let's say camera, expose camera reset. Okay, nothing clearly usable here. So let's just click at the camera. Would it be anything like get main? Get main, we have it. Get main camera, this should do. This should do. So let's, actually it doesn't, okay, we can't see the monster sprite on the screen, but let's observe these translated values. So in terms of x and y coordinate, these look splendid, these look exactly as they should. But the problem is that the z-coordinate is -10, and as I demonstrated you a few minutes ago, a sprite at the z-coordinate -10 will not be visible. So what we have to do now? Well, we have to decompose these data. These are three-dimensional data, 3D data. In Unity terminology, three-dimensional data are stored in a structure called vector-3. It's an abbreviation from three-dimensional vector, vector-3. We have to decompose this vector-3 into x, y, and z, and then feed the set position with x and y only, leaving the z unused. So remove this connection by right-clicking here. I will move it slightly to the left and taking the output, clicking here. Unity gives us a guess that we probably want to do something with the vector-free value. It's a very good hint. And what we need is clearly visible right here. Okay, so this is how I can get an X out of the 3 coordinates produced by camera screen to world point. I will now do the same thing with the Y coordinate, which is slightly lower here. And that's it. I don't need to do anything with the Z coordinate because Z coordinate should be just ignored. Now let's select all these nodes and move them a little bit to the left just to create some space here. Unity visual scripting has another nice feature. You can notice that all these nodes here remain a little bit dimmed. This means that when the program starts, they are never executed, they are not connected to the flow. When we finish, they will be again fully colored like these two, which are obviously already connected. So what I should do in order to connect X with the set position, this doesn't work, okay? It's just a different data types. This is a number, this is a vector. So I have to combine these two numbers, the X coordinate and Y coordinate, to create a 3-dimensional vector now. So let me try maybe vector 3, something like that. Vector 3, nothing here, but create vector 3. Create vector 3 out of X and Y. Create vector 3 out of X, Y, Z. Actually, I need to create vector 3-dimensional vector from X and Y only. So this looks like the node that will ideally fit to my problem. Let's move it here. Connect X to X, Y to Y. Set position a little bit further. Also, let's resize the window. Connect output of vector with set position. Let's have a quick view. By the way, everything now is switched on because we have connected all the nodes to the flow. Let's quickly review what has been done so far. We start with mouse position, send it to screen to world point, which will use the main camera to convert the screen coordinates into the world coordinates. The world coordinates as a 3-dimensional vector get decomposed into the X and Y component, and from this X and Y component we again create another vector 3D, another 3-dimensional vector, but as you can see we ignored the Z. Z was the bad guy. Z had the value of -10. And this value consisting of X and Y world coordinates of the mouse position is sent to the transform set position. Let's try it. Yeah, and the thing is working. So in this way, the first stage of our solution is now completed. You might notice that even though our application is working fine, the screen to world point node is still displayed in red, and it still displays some kind of an error message. I have no idea why, frankly. I guess it may be because Unity is still a little bit buggy. If you know a better explanation, please send it as a comment to this video. At this stage we will leave the player, so I will close the player graph, switch to the project structure, sprites, and let's put the first apple to the screen. The apple will also need a little bit of scaling, so let's make it a bit bigger, like this. Running the application. Yes, this apple looks good to me. It will have to, of course, it will have to detect collisions, so box collider 2D has to be added, and it also has to be a trigger. We don't want the apples to bounce off the monster, and we will also add the visual script machine component for our apple. The apple will have a new graph, so in a moment, apart from player graph, we will have a new graph which we will call, because we will have several different fruits, so it will be fruit graph rather than apple graph. Save, edit. Oh, this time it appeared immediately. As previously, I'm using the middle button in the mouse to put the on update in the upper left corner. The first thing we will implement in the on update flow is the movement of the apple or any other fruit down the screen. Firstly, I will ensure that apple is selected in the scene hierarchy. To move objects in Unity, we normally use a function which is called translate. Translation is geometrical name for moving objects around. So right click, translate, transform, translate. This looks good. Maybe this transform, translate, and we will have a translation vector. All right, let's connect the flow so this function is actually executed, and now I'm moving the window a little bit down so that we can observe the situation. When I start the application, nothing happens with the apple because the translation vector is 0, 0, 0. If I change it to, let's say, 1, 0, 0, please observe, okay, the apple very quickly moved to the right. Now, whatever I do, I stopped this movement right now, but it's been removed from the screen, so I need to replay. Okay. And now I will try to do it more carefully, like 0.01. Okay, so as you can see, we can control movement of the apple in this way. What we really need is a small negative number in the y coordinate. So this is kind of working. But I'm still not happy with this. I will add a few variables to parameterize this motion a little bit. So first of all, you might say that the fruits will always be falling down, so we really don't need to precise the direction of their movement. But we never know how the future expansions of this game would happen. So first thing that I will do, I will add a variable which defines the direction of the apple, and this direction I will define with a normalized vector, so a vector of the length of 1, which value will be 0, -1, 0. It's just showing that or saying to the system that the movement should occur in the downwards direction. So I go to the special section of the window called blackboard, and I'm adding a variable which will be called direction of movement. Press plus because I need to specify this direction in all possible coordinates, so x, y, possibly z. I could choose vector 2 and have a two-dimensional movement, but if you look at my translate node here, it takes translation as a three-dimensional vector. So it will be safer for me not to take this suggestion vector 2, but to use vector 3 instead. Vector 3 with -1 as the current direction. I will also create another variable which will be called speed, so that I can easily control the speed of movement of my apple. And that is important because if you remember the original game, each time the fruit gets smashed by the monster, its speed should increase. So this is speed. Speed is just a number, so I will choose a float point number with the value of let's say 1. We can always change it. Now what I need to do is just to grab the variable by this double dash here, and when I drop it here, I get the node that generates or provides the value of my variable. I will do the same with the speed, okay, and now I could, for example, multiply both values. Multiply and as you can see, it works. There is no problem in Unity to multiply a direction, which is a vector, by a number. It will scale this direction vector, but maybe not, but maybe just check what we get. Oops, it was very fast. It was very fast, but it worked, okay? So an obvious thing that we could now do is to change speed from 1 to, let's say, 0.01, and it moves quite nicely now. Yes, this is what we would like to see, but this is not the best way of implementing motion in Unity, because depending on the frame rate, which may depend on many different aspects, for example, how complicated the game gets after a time, what other tasks your computer is currently doing, this movement will be dependent on the frame rate. If Unity generates a lot of frames, then all this calculation and translation will be performed many times per second. If frame rate is slower, we will get fewer translations per second. So what is normally done is, apart from speed, which I by the way revert to 1, quite often we use special value, and this is actually a kind of a standard procedure in Unity, both in visual scripting and C# scripting. Get delta time, okay? This special function, no, it's a touch, sorry, I took the wrong, this doesn't look good, this doesn't look like the function I was looking for, so let me try, actually it should be time, so this one, but let's go through this search. Get delta time. Somehow previously I used this node, I really need this node, time, get delta time. So you have to be very careful not to confuse nodes that are similarly named. What get delta is? Get delta is the time elapsed since the previous frame of animation, and we need to multiply it to the whole thing, but a small problem. Multiply only has two inputs. So one possible thing is I could add one more multiplication here, and this should work. It's crossed. Not the best example of visual planning of the graph, but I will replace it in a moment anyway. So for now it's just checking if this thing is working, and it is. Okay, so speed now is 1, and this is because, as you can see, the delta time is 0.02, something like this. Basically it's a number of seconds since the previous animation frame, so this number is quite small. Stop and improve this graph a little bit. We have two multiply nodes and also this crossing. This looks like spaghetti, so I will delete this, and I will add my favorite node. My favorite node is called formula. The formula node has a special parameter here which tells how many inputs it should show. So I can very easily change it to a triple input node, and I connect this and this and this, and as you probably guess, I can just say that this formula node should calculate something like A times B times C. This is a very useful node for creating any more complex maths calculations, combinations of numbers. And let me connect it, test it. Oh, and it's working. It's working. The next thing to do is to revert the apple back to the top of the screen once it passes the bottom of the screen. Before we do that, I will tidy up this graph a little bit. So go here, these three elements are a little bit down, and okay, this is down as well. And now with Control pressed, I can draw a frame. This frame can have a name, like say fall down. In this way I can divide my graph into several logical sections, which can then be moved as one thing around. Okay. One additional remark here: these frames do not change the way your script works in any way, so they are used for aesthetic reasons only, or to improve readability of your graph. Next stage, basically we have to decide when this fruit should be moved to the top of the screen, and for this decision we will use the if statement. I could take this node and add a if node at the end of this, and this might be quite logical. So after falling down, we check whether my fruit is touching the bottom of the screen, and if it does, we will do something with that. But I prefer a different solution with so-called sequence. So I will actually remove this connection, and instead I will add a special, very useful node, which is called sequence. Sequence can have any number of steps. In this case, 2 steps are perfectly enough. Step 0, so the first to execute, will be our fall down operation. And in step 1, it will go to our if operation, which has to decide when to move the fluid back to the top of the screen. Alright, let's move it up, and this wrap movement has to start from extracting the y coordinate of our fluid. Let me also do a quick experiment here. Apple right now is at the coordinates 3.7. It is apparently at the position 5 when it arrives to the upper top of the screen, and -5 when it is around the bottom of the screen. So whatever the coordinate is, I should compare it with -5, and if it is less than -5, we will revert the position to +5. Okay, so first of all, I need the position, which is displayed here, but has to be translated into graph. So let's look for a node which would be perhaps get position, rect get position, node, touch, transform get position. Okay, this creates or extracts the position for my fluid. Now we will only compare the y coordinates, so I will use what you've already seen, vector 3 get y. We want to know whether it is less than -5, so let's hope that we have a function called less. It's actually here, okay, less than -5. Sorry, maybe I will just move this here. So this is our condition. We can even try and find out if this is kind of working, but unfortunately what I think, when it arrives to the bottom, we can't see any change here. Alright, I counted for more visual expression of this if node, but sorry, no such thing. But what we can do is add node set position, so we will only set the position of the fluid if its position is less than 5. And now I should see, I should get some kind of actually I can put here 5, and this should work. So when we arrive at the bottom of the screen, a single bubble should flow here to enable this set position only once, to set the position of the fluid to 050. Will this be the case? Yes, it's working. It's nearly working because it's been centered, and this of course been centered because we have position 050, so it will always be recreated here. This is not exactly what we want to get. We want to keep our x coordinates, so I will use a double wiring here to get the x coordinate, and a function that you already know, which is called vector 3 create. Vector 3 create out of xy, it's perfectly enough. And this new vector 3 will be created directly from our current x coordinate. It will go to here and it will use the value of y equal to 5. And now it should preserve our x coordinate and replace the y coordinate with the value of 5. Let's test it. Yes, it works fine. It works very fine. One thing that I don't like too much in this solution is that we have used these values -5 and 5 just by checking the current size of the screen. This is not the best solution because the game may be executed, may be performed on different screens, different windows, different sizes. So we should rather read the size of the screen first and only then apply the actual size of the screen to these calculations. To achieve it, we need to use variables rather than fixed values for the screen size like width and height. These variables must be initialized in the onStart flow sequence. Even though it is a generally good practice and a highly recommended one, it is not entirely essential. The program is working reasonably fine without this functionality. So you can now opt to omit this part of the tutorial, particularly if you are watching it for the first time. If this is what you wish, stop watching now and jump directly to the part 2, which will cover collision detection or frit smashing. If you decide to stay here, just watch on. So let's move here to the onStart node, which I will move a little bit up to make a little bit more space and read the size of the screen. So let me first of all create the new variables, width, which will be a float number, and height, which will also be a float number. We don't need to initialize these because they will be automatically initialized in a moment. Now, how to get the width of the screen? Add node, and let me try get width screen. Here it is, get width of the screen. So we can get the width of the screen and we can similarly get height of the screen. Now, if you were carefully observing so far, you will know that probably what we get here is still the screen coordinates, not the world coordinates. This is the width and the height of the screen, so it's quite natural that it is counted in the screen, not world coordinates. So we need one more node, screen to world with position. Of course, we also need the main camera main, get main. Let's do this connection. Okay, I cannot directly attach the width to the screen position because this expects position, so three-dimensional vector. But again, something we already learned, vector 3 can be created out of xy, so width will be x, height will be y, and this now goes here. So let's tidy this up a little bit. So this goes here, this goes here, and my camera is here. All right. And now let's take this output and get again x, and this x will be, notice that we first take the width of the screen as the screen coordinate, then we construct the vector 3D just to conform with the input and output of the screen to word point, and the very next thing is to extract x and extract y, just to ensure that we have the width and height of the screen now in the world coordinates, so exactly in what we really need. The last thing is to set the values of these variables, and as you can see, this doesn't work this way. Okay, why it doesn't work? Because this node says get variable. Quite funny, get variable is get variable, it's not set variable. So I need a different type of a node to set the variable value, and this different type of the node can be get in a very similar way. So by dragging the variable from the blackboard to the graph, I can get width, but if I press Alt key on the keyboard, get becomes set. And now I am absolutely ready to set this value. So I have now set the value of the width, and same with the height. And we have a problem. We have a lot of stuff done here, but it apparently is not connected. Wow, if you look at on start, it's really this flow doesn't go anywhere. And if we start application, nothing happens with my variables and nothing happens here. So what I need to do is to connect the flow from on start to my first variable and my second variable, and something didn't happen because we cannot do this in parallel. So again, what I can do, I can connect this to here and then continue with the flow, and I get a terribly looking structure. Okay, we don't like spaghetti in visual programming. We much more prefer the sequence node. Sequence node will add some order to this graph. Okay, the first thing, we can even move it a little bit up. The first thing that is to happen is to set the width variable. Everything now is nice and colorful. And the second thing is to set the height variable. Now the only remaining thing is to move this a little bit up, move this a little bit up. Now pressing Ctrl, frame around all of this, set screen size. We're ready. This code doesn't have any visible result on the game, but as soon as the first thread appears on the screen, okay, my variables have populated. The width of the screen is 10 with something, the height of the screen is 5. If you think why we would ever need width, we will need the width of the screen very, very soon. So if this is done, let's now move down to our wrap movement sequence. And in this wrap movement sequence, let's stop playing, I said, okay. The easiest thing will be to replace this 5 with the height variable. So here it goes without an alt because we need to get the value. This is done. And now we need -5 value here. I will move these nodes a little bit to provide more space for me. And what I need is to create another formula node to say just a single input to say -a. I will put this thing here. This will go a little bit down. Okay, this should work. You might ask, do we really need a formula node to negate a number to get a negative value of a variable? Frankly, I don't know. I looked for a useful node to convert to negate a number. I didn't find. If you know better, please add this information in the comments below the video. I will appreciate it. Let's make a test. Does it work? It should appear here. Yes, it works fine. So the last thing is to tidy up this graph a little bit. So I am rearranging the nodes and adding a frame, which is called in Unity's official terminology a group. This group has been named wrap movement. This completes the first part of this tutorial. In part 2, we will concentrate on detecting and reacting to the collisions when a fruit gets smashed by the monster.